This video deals with the fifth type of reaction from Chapter 8, Section 2, so you're almost done. This is combustion reactions. Combustion reaction is when you combine something with oxygen and it releases a large amount of energy, usually in the form of light and heat. And you saw one of these. We saw one of these in our talk about synthesis reactions. And that was when we mix magnesium and oxygen, and you actually saw that one in the lab, Chapter 7 lab that we did, when we burned magnesium in air. That would be considered a combustion reaction, but it is also a synthesis reaction. The main thing we're going to look at with combustion reactions is the combining of a hydrocarbon with oxygen. Okay, so here you'll see, first of all, a simple case. This reaction, we take hydrogen and burn it in oxygen. If you do that, it will produce an explosion. There'll be a large amount of heat produced. As a matter of fact, some of you might know the Hindenburg. This is the reaction that occurred on the Hindenburg when it crashed and burned back in the late 1930s. But this, we could classify this as either a synthesis reaction or combustion, but because of the large amount of energy that is released, would probably be considered combustion rather than synthesis. Propane, and this is where we get to the main example of combustion reactions. We will normally consider the combining of a hydrocarbon with oxygen to be the combustion reaction. Hydrocarbons are molecules that contain only carbon and hydrogen. Propane, C3H8, and you probably know propane is used by many people in the out of the metro areas where natural gas is not available. They use propane. They have these big propane tanks in their backyard, and they heat and cook with propane. It is a gas at normal temperatures, and it can be combined with oxygen to produce a large amount of heat, some light, although we try not to get a lot of light. That's why we look for the blue flame when we're adjusting our Bunsen burners in the lab. And the same thing would be true of these, the furnace that's burning this. They would adjust that so you get that nice clean blue flame. That produces only carbon dioxide and water. Okay, so anytime you see a hydrocarbon plus oxygen, you can immediately go and write CO2 plus H2O and then proceed to balance it.
Methane, like many fossil fuels, can react with oxygen in a combustion reaction, releasing heat and forming carbon dioxide and water. The amount of oxygen available is very important for this reaction. When the supply of oxygen is limited, carbon monoxide, a poisonous gas, is formed. At very low oxygen levels, soot, or tiny pieces of carbon, are formed.
And that is the end of Section 2. You're there. Congratulations.